Happy New Year, everyone. So, Advent of Code finished up last week, and I made it to day 17, finished day 17, and unfortunately, day 18, I sort of hit a wall and wasn't really able to finish anyone past it. I got one more star for day 19, but that was it. So, day 18 through day 25, I didn't either attempt them or I just didn't get any stars for them. So because of that, I didn't release any videos on 8 days 18 through 25, so I wanted to do one more recap video of those days and at least visit them and talk about how I at least start solving them, or how I did start solving them, and just kind of go through that way to kind of complete the whole 25-day series here and just not leave it kind of randomly ending on day 19 or day 17. So for day 18, this is the first one I attempted, and I got code for and just couldn't get a star for this. So the problem for this day was that you were given a sort of maze like these, and the uppercase letters here represented doors, and to unlock those doors you needed to get a key, which was represented by the lowercase letter of that. So you had to develop some sort of pathfinding algorithm to figure out how many steps it would take to unlock all the doors in the least amount of steps. So you had to figure out, you had to pathfind with the key, get the key to unlock the door, to then get all the rest of the keys and progress that way. So I developed code that actually worked. It did it. It got all of these right except for my question. This one took a while. This one took like 8 minutes to solve for my algorithm, and unfortunately my code for my actual input, which was this here, it would have taken a day or two to solve. And the issue isn't because of the size of the maze. The issue is because I used a sort of I don't want to call it game theory, but basically a figure out all the possible solutions and solve that way. And the issue was the number of keys that were first available. So the algorithm ended up doing, basically you took your starting point and then you pathfinded to a key, use that key, and then you would finish that loop, and then you would pathfind another key, finish that loop. Basically you recursively descended to figure out every possible solution and go from there. And so the difficulty is not in the maze. The difficulty is in how many keys you have access to, and 9 keys just was too much and took too long for my algorithm to process. So unfortunately I had code that would have worked, however it just took too long. I couldn't optimize it, and that's why I didn't get any stars for today. So the theory on how to solve this one isn't too bad. You just have to basically pathfind each key that you have available. You have to also keep track of what keys are locked behind a door. So in this case, you didn't know that C is behind door B, D is also behind door B, but it's also behind key C. So you just have to keep a kind of a track of where the keys are in relation to what they're behind door wise or key wise, and just figure out the path from there. So knowing the theory isn't too bad. It's just optimizing was my issue and why I couldn't solve this problem for the day, and ultimately why I wasn't able to get any stars. So moving on to day 19. Day 19's was a tractor beam. You had to figure out where you could fit I think in our case is a 100 by 100 square, but their example was a 10 by 10 square, where you could fit this 10 by 10 square in this tractor beam, where the pound symbols here are in the tractor beam, the dots are outside of it. You had to figure out where where you could first fit the 10 by 10 square inside of the tractor beam, and then you returned this coordinate here. This is another one where I just couldn't optimize it. I've thought about it a little bit since. I think I could maybe optimize it, but the strategy I initially went for was finding basically 2 vectors here. So the vector for the upper bound, a vector for the lower bound, and then figuring out the first location of where we could go up 10 over 10 and hit a point on the upper bound. Unfortunately, you're not going to get enough precision with these lines here. You're not going to be able to figure out what the rise run is of these bounds. So unfortunately, because of that, I really couldn't write an algorithm that was good enough for this. So that was the first error or issue I ran into, and I couldn't use it to apply here. And then my second idea was to then basically, because this was an encode program, so it was going to be to run the encode program, build up a map of the entire space for the, I did like 10,000 by 10,000 area. I think it was like 5,000 by 5,000 area. But basically run that entire encode program, figure it all out, and then manually calculate it. And I try to do kind of some optimizing stuff by just knowing that, hey, I don't care about all of this. I can kind of shortcut it and jump to places here. But again, it still took too long, mainly the encode program. I even tried to optimize it there, but in the end, again, this is another whole optimizing problem. I think if I actually readdress this, I might be able to get it. The first part was actually pretty easy. It was just finding how many points were affected in a 50 by 50 area. That wasn't too bad. That one could be run in a few seconds, I believe, maybe a minute or so. But either way, that was able to be run pretty quickly. So I think if I revisit this one and I optimized it to basically when I generated the encode program, I could maybe save where it first found the tractor beam on each row and then go from there, and that should help a lot. But again, it just wasn't good enough, so I wasn't able to get the star for this problem. So day 20 was one of the first ones I didn't try and solve. I did read this beforehand, but I didn't actually try and solve it. And basically, this is another maze path, or maze pathfinding algorithm to know how you can get from, I believe, AA here to ZZ. So it's just another pathfinding question. Basically, you want to get from AA to ZZ in the least amount of steps. However, for this one, there are what they're called portals. So you can go from AA to here to BC, and then it's a portal to here, go to here, portal, portal, portal here. So the difficulty in this one is not so much the pathfinding, but it's to be able to use the portals. And if I were to start solving this one, first thing to do was to one, map everything out, but then two would be to understanding the portals. So I would say that I would need a way to figure out, like, here's a portal BC. If we hit this B, we need to be teleported to B here. So B here, actually be teleported to here. So the algorithm difficulty would be that your maze could understand where it's teleporting to, and that's actually not too hard to do, because all you're doing is that when you're doing a pathfinding, you're holding either your current position, or you're holding a cache of positions you can go to. And if you're holding either way, all you're doing is that when you move to this location, you're either setting your current location to be here, or you're adding to the cache here as well. Basically, you're just moving your program to understand it's going to this location here and is not actually going here. Simply, though, that's not too hard a thing to do. The hardest part of this would probably be to understanding where the portals lead, because this one is B and C. But either way, if you save this entire thing to a map, you can just grab BC, teleport to BC, grab DE, teleport to DE here. So linking them will probably be a little bit difficult, but honestly, actually doing them probably, once you're able to link them, figuring out the shortest path is, again, just the previous shortest path algorithms you've written, just applied to here, and knowing that you need to be able to readjust your current position or whatever else you used to, instead of going to here, you're dropping it here. So this one, not too hard to do. Just making those differences is what will really help. Okay, so for day 21, the theory on this one so for day 21 here, the problem is that you are having a spring droid, as they're calling it, and it needs to survey the hull of your ship for holes. And the only thing it can do is jump and return if there's a hole either 1, 2, 3, or 4 moves away. So like here's an example here. So the @ symbol is the spring droid, here's the hole, and these dots are just space. So your droid here, if it's here, it can return to these 4, so hole, 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 hole. whereas, or I should say, your ship. These are all your ship here, the whole of your ship. Whereas this one is a hole in your ship, and when it moves here, it return true for this value here. The way it does that is it uses instructions, or not instructions, it uses registers of A, B, C, and D. A is 1 away, 2 away, 3 away, and 4 away. And it only understands what's called spring script, which is just a instruction. The row can only hold 15, but either way, basically you write a spring script that every time it's run, it will set the register of J or T. T is just a temporary, and J is the register that if it's true, when after the spring script runs, it'll jump. You have to go through and basically have it survey the entire hull of your ship. You don't want it to jump into holes or fall into holes though. So it can jump a max of 4. So the way you would go about solving this is to, one, have it go. If it detects there's a hole 4 away, we need to probably store that. But if there's 4 away, we do nothing because we don't want to jump yet. Because if we jump now, we're gonna jump into the hole. What we need to do is we need to detect if there is a hole 3 away. Because if there is one 3 away, we should jump. But if there is a hole 4 away, we should also not jump because we don't want to fall in. So we would need to use these not and instructions to basically say if there is a hole 3 away, jump. But if there is a hole 4 away, don't jump. So the problem would be to writing these nods and ands to understand that if there is a hole 4 away, never jump. But if there is not a hole 4 away, jump. If there's a hole, then 2, 1, 2, or 3 away. So that would be how you go about solving that one. This one's not too hard. It's just figuring out the correct logic instructions to do it. I could have probably done this one if I had actually looked at this one, but this was close enough to Christmas. I wasn't. I was doing other stuff. So either way, this one probably wasn't too hard for the first part. I don't know what the second part is because I would need to get this one right. But it gives you encode program, and it goes from there. So that is day 21. Let's move on to day 22. Okay, so for day 22, we are doing a card shuffling, just problem solving, I guess. Basically, there are 3 instructions you need to be able to handle. So you have a deck of cards, 0 through 10,006. So yeah, 0 to 10,006 are the numbers on the cards. And you are shuffling these cards with 3 instructions for the shuffle. There is, let me scroll up. You can deal into a new deck, which is basically reversing the order. As you see here is an example. The top is 0. This is an example with only 10 cards. Top is 0, bottom is 9. It gets dealt, and now the top is 9, bottom is 0, so it just flips the order. Cutting it will basically take whatever the end cut is and flip it to the end. As you can see here, it gets flipped to the end. And then this also has to support negative numbers. So if you said to cut of -4, it would take the last 4, put it to the front, and you'd be good there. And the third and last instruction is to deal an end increment. This is probably the more difficult one, to where after every increment here, so 3, every third card in here will be, every index card here will be moved over this amount. So you can see here 0 to 1, move over 3 is now 2, move over 3 is now 3, wrap around, move over 3 is 4, move over 3 more is gonna be 5. Keep doing that until we get a number here. Obviously I'm gonna guess, I don't actually know what it will do if if we would roll over into something, but either way. So that are the 3 instructions. So basically you have a deck of 10,007 cards. You just have to follow the instructions it gives here to create a new deck, and then return the index of the 2019th card, the number of that card, what position it's at in your new deck. So you need to be able to write a parser that would parse out each instruction and apply those instructions to your list of cards. Python, this probably would not be too hard because Python can deal with negative numbers on arrays very easily. I'm sure a lot of this would be very easy with Python. But in Java, unfortunately, it won't. So you need to do different splits for that. But either way, you're just going to be doing a basic array and just doing basic stuff with it. Of course, with 10,007 cards, it might get a little slow. So ideally, you would have some sort of optimizing, but in the end, there's probably not much you can do. The biggest part of this is going to be parsing these instructions and then just having the code to do it and then doing all of these. So that is that. So that is day 22. Let's move on to day 23 and how to solve day 23s. Okay, so for day 23, this one is reminiscent of one of the earlier ones. I forget what day it is, but we have multiple encode programs running at the same time, and they're basically acting as a land computer network here. They all have, you have to assign them a network address of 0 to 49. Each one needs a different network address that's unique to itself. So you assign each of them a network address, and then from there you need to run their encode programs and transfer the packets they send out accordingly. So they will output a packet of the destination and then an X and Y value. So the output of 10, 20, 30 would send the packet 20, 30 to the computer with the address of 10. And basically every computer will take in the input as a queue. So you have to enqueue all those packets and then pass them off as the computer asks for it. So networking these together to be able to run them all together is the challenging bit. I don't know. I think I would originally try to just set up all 50 encode programs and then run the first one until it asks for input, hold it, and then run the second one to ask for input, hold it. And meanwhile, while the output stuff, I would enqueue it into the computer or store it to a queue and just kind of keep looping around that way. I don't know if that would work. I don't know if that's kind of how they want you to do it. But that's how I would first try and do it. If that didn't work, I'm not quite sure what I would move to there. I guess you, in theory, if you were really wanting to, you could thread them all and create 50 threads, thread them all, so that way they're all running quote unquote at the same time, and just build up a list of queues that are thread safe, and just add things to the queue as need be. And then when a computer asks for an input, it says here if the incoming packet is empty, you just provide it -1. Otherwise, you provide the X and Y values. So in theory, you could run all 50 computers at the same time, threaded, and just provide -1 if they have no packets in their queues. Otherwise, provide what's in the queue. So that's one option too. You just need to make sure that your queues, your list of queues, are thread safe. But other than that, that's how I would start to solve this one. So let's move on to day 24 and continue with that. Alright, so day 24, this one I've read. I don't actually know how I would solve it. I understand the question. So the question is that you're on a planet that is infested with bugs. They are in a 5x5 tile state. Here, as you can see here, this is your example. And the bugs will die unless there's exactly one bug adjacent to it. So this bug here would not die because there's one bug adjacent to it. This one as well would not die because there's one adjacent to it. This one would die though because it has 2 adjacent to it. So you can see here, after a minute, it is dead. However, an NP space will become a bug if exactly 1 or 2 bugs are adjacent to it. So in this case, this one wouldn't because it has 3 adjacent to it, but this one would because it has 2 adjacent to it. And basically the program will keep doing this, and bugs will live or die after every minute based upon these rules. And the question is to find the first occurrence of a layout that matches a previous layout. And by layout, it means a certain area. So in this case, this is the first thing to pop up multiple times. So as you can see here, it pops up here, and then not here, but then here again. As far as finding this, I don't know how I would go about solving this one. This one would be, I would have no idea in my head. But that is the question. I suppose what you could do is keep a difference array. So after every state, so after these two states, you keep a difference array, which would put a 1 or 0, basically a Boolean value at each position. If they are the same, it'd be true. If they are different, so as if this location is changed, this would be a 0 because it has changed between the two states, and keep a difference array or difference map between each state, and then kind of keep doing differences. That way, all you'd be looking for is one that sort of matches. But again, these two don't fully match. So the difference between these two isn't exactly the same, but there are ones that are the same. So in theory, I guess you could just look for a difference array that has ones that are in a small grouping. That's the best I can think of. I don't know. This is one of the ones I really couldn't give you a good starting scenario, but that's the best I could think of. So that's my idea. I don't know. I will move on to the last one here, which is day 25, and we will go on from there. All right, so Christmas Day's theme was you have found Santa's ship and you need to navigate around to it to, in this case, find the password for the main airlock. As you can see, the puzzle input is a giant encode program, really large. And our encode program is moving or is controlling droids that need to navigate Santa's ship and, again, find the password for the main airlock. You are able to give it a bunch of movement instructions. You're able to pick stuff up from the environment, drop things off, and then get a list of stuff in your inventory. This problem is actually very, not complex, but just has a lot to it. I don't really know password. I'm gonna guess it's literally trying to find password for main airlock. So my guess is you're gonna want to move around the ship using your movement commands and just look for something that says password of main airlock, like this says here. Just like every other problem before, we have used our pathfinding, so it's just gonna be another pathfinding problem. Keep moving around, and after every movement, just look for that character. That's really all I can think of for this one, without really going in depth and actually trying it. So either way, this is just another pathfinding. There's been a lot of pathfinding in these days, but at any rate, those are all the days. Again, sorry I wasn't able to do the rest of these. I hit a wall and I couldn't keep going. And then of course holidays came around and family came up and all that stuff. So at any rate, hopefully you guys enjoyed this year's Advent of Code. I hopefully will try it again next year. Hopefully next year will go better. I might try a different language, or I might try and do something else. So if you guys have any suggestions of like things you'd like for me to try next year for like challenges for each day, I don't know, like maybe a different language or I don't know, whatever you can think of. But again, hopefully you guys enjoyed, and I will see you guys in the next video. Peace out.